Lesson 8, discount rate. Discount rate is an idea like the interest rate. Now, the main difference is that when we talk about the interest rate, the interest is paid at the end of the period, but when we talk about the discount rate, the interest is paid at the beginning of the period. So this is a concept that you can remember for a possible conceptual question. Now, mathematically, if I is the annual compound interest rate, then the annual compound uh, discount rate is given as D is equal to I over 1 plus I. And the above equation, after some algebra, will give us, if you solve it for I, you will get I is equal to D over 1 minus D. Now, also recall from the previous section that the definition of the discount factor is nu is equal to 1 over 1 plus I. So 8.2 can be written as D is equal to I times nu. And the effective rate of discount during the nth period, let's call it D subscript n. So that equals the interest earned during the nth period divided by the accumulated amount after n periods. And so here we see that the difference between the effective rate of interest during the nth period and the discount during the nth period is the denominator. In case of interest rate, we were dividing by a of n minus 1, whereas in case of discount rate, we divide by a of n. And so IN is the interest in the nth period, which is a at n minus a at n minus 1, accumulated amount at n minus the accumulated amount of at n minus 1, and divided by an. And the amount formula in terms of annual compound discount is given as a of t is equal to principal divided by 1 minus d power t. Similarly, in case of simple annual discount rate, the amount formula will be a of t equals p divided by 1 minus dt, where d is the simple discount rate. Now, let's look at this example. You would like to have 500 at the end of 10 years. How much should you invest now if the annual compound discount rate is 4%? So let's use 8.5, it's the annual compound discount rate that's given to us. How much you should invest? So we have to find P. A is given to be 500. You have to have 500 at the end of 10 years. D is 0.04. T is 10. So substituting these values in 8.5, we get 500 is equal to P divided by 1 minus 0.04 to the 10. That gives P equals 332.42. So we are now ready to do the SOA problem 247. Let's look at it. The amount that must be invested at I%, where I% is anything between 0% and 10%. So the amount that must be invested at I% to accumulate to Y at the end of 3 years had an annual discount at an annual rate of, so simple interest, at simple interest, the amount in where the investment is X is Q. At compound interest, the investment is R. At simple discount, the investment is S. And at compound discount, the investment is T. And determine the relationship between the 4 different kinds of investments. So the first thing to note is that we want the same accumulated amount in all the 4 cases, and that is Y. And the second thing to note is that I is anything between 0 and 10%, and based on the answers, the same answer should be obtained no matter what value of I you select between 0% and 10%. So you are free to choose any number that you like in this range. I am going to choose 1%. And so we already have the 4 formulas in the four types that are given to us: simple interest, compound interest, simple discount, and compound discount. That's what these four cases were. So we know that for simple interest, P is equal to A over 1 plus IT. Compound interest, P is equal to A over 1 plus I whole power T. Simple discount, P is equal to A times 1 minus dt. And compound discount, P is equal to A times 1 minus t to the t. And you can look up these formulas in the corresponding sections on these topics. Discount is this section, and then the other three were previous sections. And most times we had formulas in terms of A. So for example, in the discount, we had this formula in terms of A, but we could easily solve it for P. And the same you can do for the other three formula types, and that's what I've done. I solve all the formulas in these four kinds of interests or discounts in terms of the principal, because the principal is what is changing in the four problems. The amount is the same. Amount is always Y. So we were given that for simple interest, the principal is Q. So in the simple interest formula, the P now becomes Q. A is always Y. And we have we decided that we will take it to be 1% in each case. So I is 0.01 times 3 years. So when you solve all this, 1 divided by this 1.03, you get 0.9709y. Similarly, in the second case, in the compound interest case, the investment was R. So the principal is R now. A is again Y, 1 plus 0.01 to the 3. So R comes out to be 0.9706y. And in the simple discount case, we were given that the investment is S. So S is equal to Y times 1 minus 0.01 times 3. And that comes out to be 0.97y. And then in the compound discount case, we were given the investment to be T. And so T is equal to Y times 1 minus 0.01 cube equals 0.9703y. So if you compare these four, we see that S is the lowest, 0.9700. Then we have T, which is 0.9703, and then we have R, 0.9706, and then Q, 0.9709. Y is the same in each case. So this was choice C.